Alright, so number 61 is cosine of x over 4 equals 0. So we know that the ratio, the angle pi over 2 and 3 pi over 2 give you a value of 0, right? And if we want the answer, if we want x to be between 0 and 2 pi, again, including 0, not including 2 pi, we have to divide the angle by 4, because that's what this says, x divided by 4. And so that means we have to divide this by 4. So 0 divided by 4 is 0, 2 pi divided by 4 is pi over 2. So in this domain, there's no value for x, because x cannot be equal to 1/2 pi over 2. So, because it's strictly less than. Okay, so this part has no solution. But once we extend it out to the general solution, we know that it's pi over 2. Now the reason I put pi n instead of 2 pi n is because these two are opposites of each other. Okay, so this covers both of them. By having this together, it covers this one, it covers this one. And we have to multiply it by 4 because we want x, not x divided by 4. So we have to multiply by 4. And so that gives us this answer right here. So whether n is 0, negative, or positive integers, it doesn't matter. We could go on forever, and this provides all possible answers, all possible solutions for this equation. But if x has to be between 0 and 2 pi, including the 0 but not the 2 pi, then it has no solution. Alright, tangent, for number 63, tangent is 1 in quadrants 1 and 3. And so you have that right here. So the 4x means that you're going to extend the domain to 0, from 0 to 2 pi to 0 to 8 pi. So that means you're going to go around 4 times. So that means you're going to have 8 answers, because there's 2 for every rotation. So here's the first rotation, the second, the third, and the fourth. And what happened each time is I added 2 pi to each of the 2 previous answers. And the fastest way to add 2 pi is to double the denominator and add it to the numerator. So double the denominator is 8. 8 plus 1 is 9. 8 plus 5 is 13. 8 plus 9 is 17. 8 plus 13, 21, etc. And that's how I got these 2 here. Now, you want x, not 4x, so you divide everything by 4. So all the 4's in the denominators become 16's. So there's the answer between 0 and 2 pi. For the general answer, well, this answer, this angle and this angle are pi apart. So all you need is this angle right here, pi over 4 plus pi n. And that's 4x. So you divide both sides by 4, and that gives you pi over 16 plus pi over 4n. And that would be your general solution. Alright, for 65, the first thing I did was converted it to the reciprocal function. So here it is, secant reciprocal is cosine, and reciprocal of 2 is 1/2. So cosine is 1/2 in quadrants 1 and 4. So if I'm only looking at x between 0 and 2 pi, that means 4x is between 0 and 8 pi. So this angle here is pi over 3. This angle here is 5 pi over 3. So I'm going to be adding 2 pi 3 more times, because it's going to go around 4 times total. So you multiply, you double the denominator, add it to the numerator. So 3 times 2 is 6, 6 plus 1 is 7, 6 plus 5 is 11. So now I take these two and add 6 to their numerators. So that gives me 13 and 17, pi over 3. And then I take these two and add 6 to their numerator, and that gives me 19, and 17 plus 6 is 23. Then I go through and divide everything by 4, that gives me 12s, and that's what you see right here. For the general solution, these are not opposite each other, so I have to write them separately. So pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. But remember, that's 4x for each of them. So I divide both sides by 4, and it gives me pi over 12 plus 2 divided by 4 is 1/2. So it's pi over 2n. And then 5 pi over 12 plus pi over 2n. Alright, so for 67, we want the ratio to equal radical 2 over 2, so that would be in quadrants 1 and 4. But because we're only taking x divided by 2, we're only going to take the top half, okay? Because x is 0 to 2 pi, so x over 2 is 0 to pi. So that would be only that angle right there. So x over 2 is pi over 4, multiply by 2 on both sides, and that gives you this answer, just 1. Over here, the general solution, pi over 4 plus 2 pi n, multiply by 2, so that gives you this, and that's your general solution. Alright, from the next page, number 9, A and B, the goal of this is to show you that this does not equal this. Okay, so right here we're going to use the difference formula for cosine, and so here it is set up. Okay, and you evaluate each term, and this is what you get, which is negative 1/2, because this is 0. And when you do cosine 240 minus cosine 0, you get negative 1/2 minus 1, which is negative 3/2. So you see that these are not the same. So 12 is similar to 9 in its goal to show you that this is not the same as this. So when you see this, you're not supposed to just distribute the cosine. They're two completely different things. So for this one, for A, you use a formula, which is right here. Evaluate each term, and you get this as your final answer. Okay? And for this one, you evaluate cosine pi over 4 plus cosine pi over 3. So here's the cosine pi over 4, cosine pi over 3. Add them together, and this is the value. So as you can see, again, these are not equal to each other. So for number 15, they want you to find the sine, cosine, and tangent of 195 degrees, but they already gave you the combination to use. So in this case, they wanted you to use 225 minus 30. So here's the formula right here for the sine of A minus B. And so then you evaluate each individual term or factor within the term. So this is negative radical 2 over 2, radical 3 over 2, negative radical 2 over 2, and 1/2. Okay, multiply these together, and you get negative radical 6. And notice the denominator for both of them is 4, so I just made one fraction here. Put everything over 4. And then a negative minus a negative is a positive, and radical 2 times 1 is radical 2. And that's the answer for that. For cosine of 195, here's the setup, here's the formula. And again, you do the individual factors within the term, and so here's what you get. Again, same denominator, 4, so you see it right there. Negative square root of 2 times square root of 3 is negative radical 6, minus radical 2, and there's your final answer. For tangent, again, same combination right here. Here's the formula. Okay, so this is tangent A minus B. So here's the A value, the B value, the A value, the B value. This is 1. This is radical 3 over 3. So that's where you see that here. And then this product right here. So I want to get rid of this 3 and this 3 at the same time. So you multiply top and bottom by 3. So this fraction here equals 1. Distributive property gives you this. Distributive property gives you this. Now you have that in the denominator, so you multiply by the conjugate. Conjugate of this is 3 minus radical 3. So that goes on both top and bottom because, again, this fraction has to equal 1. So distributive property, and you get this. Combine like terms, remember that this is 3 and this is 3. And then these two right here cancel out. That's the purpose of the conjugate, right? So that they should cancel out all the time. So here's the combined terms. I could factor out a 6, and that cancels out, and you're left with that as your answer. Alright, for 18, similar to the previous problem, they gave you the combination already. The combination to use that equals the angle that they want, so sine of this. Here is the setup. Okay, just following the formula. And so then you evaluate each of these 4 and you simplify. So here's the answer for sine of negative, 19 pi over 12. And here it is for the cosine, right here. Here's the formula. Here are the values of the 4 trig functions. And then we simplify This times this is negative radical 2. This times this is radical 6. They both have a denominator 4, so we could write them as a single fraction over 4. For tangent, here's the setup right here. And then so tangent of 2 pi over 3 is negative radical 3. Tangent of 9 pi over 4 is 1. And so again, this is just straight from the formula. And so this is what you get after you simplify the the expression here. And so you need a conjugate to multiply top and bottom by the conjugate of the denominator. Distributive property. So these are the terms. Now remember that this is 3. So negative 3 minus 1 gives you the negative 4. And negative radical 3 and negative radical 3 is to negative 2 radical 3. In the denominator, this and this cancel as they should, because that's what the conjugate does. And this is negative 3. So 1 minus negative 3, negative 2. And then you factor out a negative 2, and you end up with that answer. Alright, for number 21, I chose 45 minus 150 because that equals 105. Now, it's not the only combination, but that's just the one I chose. So here's the sine formula, sine of a minus b. And here's the way it looks. So sine 45, cosine 50 minus cosine 45 times sine 50. And then again, just like all the ones before, you evaluate each of these. And here are the 4 values. And it's all from the unit circle. And so you just simplify these two, and this is what you get. For cosine 45 minus 150, here is the formula, right here. Same thing, cosine 45 is here, cosine 150 is here, sine of 45, sine of 150, and then you evaluate these two, or simplify these two, and this is what you get right here. Now they're both over 4 because both of the denominators are 4. Tangent is tangent A minus B. Here's tangent A minus tangent B over 1 plus tangent A times tangent B. So tangent of 45 is 1. Tangent of 150 is negative radical 3 over 3. And then the denominator 1 plus 1 times negative radical 3 over 3. So minus a negative is a positive, and then a positive times a negative is a negative. So you distribute here, here, and here, and you get this. And so now you find you get the conjugate of the denominator, and you multiply that both on top and bottom so that this fraction equals 1. Distributive property gives you this. Distributive property gives you this. We know that radical 9 is 3. So this is 3. And we know that these two equal 0. They cancel out. And so you combine your like terms and you get this. And notice that you could factor out a 6 from each of these. And 6 divided by 6 is 1. So these cancel out and you're left with this as your final answer. For number 24, they gave you the angle 5 pi over 12. And I chose 2 12s plus 3 12s because those add up to 5 12s, and so I reduced them, and that gave me pi over 6 plus pi over 4. Alright, so now I did the sine of the sum of these two angles, and here is the formula. And when you evaluate each individual trig function, this is what you get right here. So that's radical 2 plus radical 6 over 4. Then I did the cosine of that same angle. And here's the formula right here. You evaluate each individual trig function, and this is what you get. And then so this is radical 6 minus radical 2. They're both over 4, so I just put them together over 4. And finally, the tangent of A plus B. Here's the formula right here. Remember, for tangent, it's all of this together. This is equal to this. Okay, not just the numerator, but the whole thing, the whole fraction. So then this is radical 3 over 3 plus 1 over 1 minus radical 3 over 3. I multiplied by 3 over 3, which equals 1. And that gave you this right here. and then I use the conjugate of the denominator, which is this one.